Hi, I'm Martin Phillips from Zumasys, and today we're going to look at the key features of QM Release 4.0. There are two main features here we're going to talk about, one called application profiling and one called data integrity constraints. So we dive straight in with the idea of application profiling. What is profiling? Well, it's about having a set of tools that enable a developer to identify parts of the application that need to be improved, looking for performance problems. Some of the tools we're going to talk about here have been in QM for many years, others are new, some of them have been extended over the years, but together they form a set of tools that hopefully allow us to find performance issues in applications. We're going to visit 5 tools here today. Fstack, the File Usage Statistics Monitor, shows generally what's going on in the file system. The Hotspot Monitor is about tracking down parts of the application that get intense usage and therefore might be most warranting attention when trying to gain performance. Command logging is exactly what it says, logging every command that's issued in the process. Lock tracing is gathering information about locking within an application and allows the developer to see exactly where locks are required and where they're released. And finally, in this list, event profiling is about trapping certain events that can occur in applications that may have a significant effect on performance. So we'll look at each of these in turn as we go forwards. The first one, Fstack, has been in QM for many years. It's had a few minor things changed over the years, but essentially it counts file system operations, so reopening files, reading, writing, selecting, indexing, and so forth, and it keeps simple counters on those. This can be done as a screen that updates periodically automatically, giving a system-wide count, or it can be activated on specific files, and when used in that way you can even shut the system down, bring the system back up, and it will continue from where it was with its counters. So you can accumulate counts over several days with no problem. And it shows effectively what the file system is doing, but it doesn't identify where that activity is occurring. So it doesn't really help you to track down directly the particular performance issues exactly, but it does give you some clues about what's going on. An example here of the file stat display as it appears on a screen capture, a little artificial because it was taken from a quick test, but showing there the 4 columns, the total occurrences of the particular event being counted, the total in this run of the Fstat tool, so you can see just across a particular part of the application, and per second figures and per second averaging figures there as well to help. And you can see that it counts things listed down the left-hand side. The number of file opens going on in the process, the number of reads, writes, deletes, clears, selects, splits and merges within dynamic files, alternate key reads, writes and deletes, and not enabled in this particular report, the cache hits from the record level caching option in QM. Now, thinking about where we're heading with this in doing performance analysis, probably the most critical one in this is opens, because opening a file may look very innocent as one line in a basic program, but there's a lot of work goes on underneath to perform an open. So if we can track down places which are doing lots of those unnecessarily, we can gain significant performance. So that's the Fstack tool. The second tool we're going to have a quick look at here is the Hotspot Monitor, a thing called HSM. Again, this has been in QM for some years, but was recently upgraded to include some additional information. And this can be activated for a specific process, including perhaps phantoms running off doing things in the background. And it shows for each program how many times it was used in the monitoring period and how much processor time was spent inside that program, and also counts of the file system activity, again, the opens, reads, writes, deletes. And this produces a report that we can view on our screen looking a little bit like this. It's showing me here down the left-hand column the number of times the program was called, the processor time in the second column that was spent in that routine, the number of opens, reads, writes and deletes from the file system, and finally over the right hand side the program name, so we can identify what's going on. Now in this example the majority of the things on the right-hand side are actually built-in parts of QM itself. But if we were looking at this as a real application and wanted to get ourselves maybe 10% performance improvement, just looking at the processor times in the second column across suggests that really the only places worth looking are those two programs there, Finance and Invoice, because they are using a significant part of the processor time of the whole application. So the Hotspot Monitor gives us the ability to identify which programs are causing us concerns, which programs we might want to think again about to see if we can improve what's going on. Moving on to the third tool, the command logging. This one can be enabled system-wide as an audit and may help with compliance with various external auditing requirements, or it can be used for logging a specific process or specific processes to gather information. And it shows every command executed and where it came from. So a very brief extract here from a report this might produce. The left-hand column in this screen capture is the time at which the event occurred, the timestamp, and it's an epoch value, number of seconds since the reference point 1st of January 1970. The second and third columns, which in this example are consistently 44 and dev throughout, are the QM user number and the QM user name of the user who calls this ham. The fourth column is where this command came from. And just looking quickly at the examples here, the user is that the user actually typed the command. And there to the right, we can see what the command was that he typed, start compile. A PA in the column where it came from says it's come from a paragraph, and it tells us the name of the paragraph and the line number within that paragraph where it came from. Going on down there's an example of exec, which is a basic program performing an execute, and it tells us which program and what line number within that program. And then finally, the last one here is a chain statement, chaining from one program to another, and there are other examples available which will appear in the documentation. The right-hand side there is showing the actual commands being executed, and the if statement is interesting because there's something rather odd going on here. The if statement has got if, and then in quotes, an inline prompt sequence equals compile, then basic BP star. So if we've got the word compile in there, it will actually go off to compile all the programs. The command with the inline prompt is what actually got executed from within the paragraph. But the next step in execution is to perform substitution of the inline prompt structure. And this inline prompt says U, which is I want to have the result in uppercase, and C2 is the second word on the command line. So the command, which is on there at the top of this screen, start compile, the second word is compile in this case. So my if statement has had the inline prompt has been expanded, and the tracing shows us the expanded form as well. But it goes a step further. It now says, how about the if? It is if true or false. Well, in this case, compile equals compile. The result is true. And so we get a third entry in the log showing the actual command that got executed at the far end of this. So the command logger is quite verbose in the amount of information it collects, and this is just a small sample showing the idea of what it does. Now this can help us to track down compliance issues, and it can help us to track down silly things going on in programs. I have seen examples of programs executing long statements where there's far easier ways and quicker ways to achieve the same thing. The next tool in our set here, the lock tracing tool, gathers system-wide information about data for every file lock or record lock action. So acquiring a lock, releasing a lock will get logged. And it says here use it for short periods, as the data collected can be extremely large. Locking can go many thousands of times per second in some applications. And to go with this, having generated its log file, there is a lock tracer tool that can be used to view this in a paginated form, walking up and down through it page by page, looking at the things you want to see. But the format of the log data is published to the user documentation, so users can develop their own analysis tools should they wish to do so. Here's a very, very brief extract again. A typical lock tracer has thousands and thousands of lines, but this time we've got the left-hand column, the timestamp at which this occurred. We've got the user who caused this lock event to occur. We have the path name of the file involved, the record ID within that file, the action, and the examples here are about releasing and getting locks, so releasing a record lock, getting a record lock, then the program that caused it, which in this case are entirely standard component parts of QM, the offset into that program as a hex address, which is meaningless on the whole to end users but useful for diagnostics, and finally the line number within the program at which this lock was either obtained or released. So the lock tracer lets us track down locking issues. Sometimes we're looking for situations where a lock has been held for a very long time. It might help us find that. And other things we might want to just find situations where we're constantly locking and releasing the same thing. And the final step in our profiling tools is event profiling. And this can be enabled for specific programs using the profiler command. And what it does is to gather information about actions that can be critical in application performance. So it lists here possibilities, subroutine calls, file activity, command execution. And there's a command called profiler that provides an easy way to display this information, drilling down into further levels. So we'll take an example and look at a series of screen captures that show this in use. The first screen capture here is the initial screen on entering the profiler tool, and it shows us the logs that are available. Now notice in the left hand side there is a little arrow pointing at one of them, and we can move this up and down with our cursor keys, but for the purpose of this screen captured example we've set it to point to log number 15. And if we then hit the return key to dive into that log, we get the next level of information. So as it says here, item types present in the log for user 15. So for each of them it shows the count. It shows us how many we've done and what it is we've done. So there are 606 calls have taken place during the execution of this particular profiling period. There are 20 executes, 40 opens, 1 open seek, just over 2,000 reads and 45 writes. So it gives us a hint about what this user has been up to in his application. Again, the little arrow has been positioned already in the screen capture, pointing where we're going next. Go down into the number of the calls done by this. So this user called 606 things. What did he call is our next question. And so here we see a list of the subroutines that he's called and the number of times it has been called. So we can see there a list of lots of things going on in his application. And although perhaps the parser might be the most exciting one to think, and I reduce the number of calls recorded, the parser is a standard component of QM, and there's probably not a lot we could do with it. However, we've positioned the item at the bottom of the list here, a routine called update clients. So we know that the user is calling the update clients routine. What we want to know now is where he's called it from. And so we can dive down another level, and this time it shows us the programs that have called this routine and the number of times they've each done that call. So here we can see that most things have only been called once or twice. In fact, everything here has been called only once or twice. And again, the arrow has been positioned on an example line here saying there is a call to update clients. The little arrow has been set pointing to the set arrived program to say, well, set arrived calls update clients, but where in that program does it call? So the last drill down level we go to here is to drop down in there to find that update clients was called from set arrived, and it was called twice, and they're both coming from the same place, line number 128. So starting with an application and saying it's not performing well enough, I need to find what's going on, we can drill our way down through the different event types to find exactly where they're occurring, what's being called, what files are being opened, whatever it may be, and where in our application this happens. This last screen, the line numbers, does require that the program is compiled in debug mode so that we have that information gathered. The overhead of having your application compiled in debug mode unnecessarily is very small. So those are our main features we've got in the event profiling part of release 4.0. This has been Martin Phillips from Zumasys.